Hello. In this video, we're going to talk about the bicycle problem. And by the way, you can see my cat's paw, right? I think he's helping us out. All right, so let's take a look at the bicycle problem. And what they have is a figure that shows the chain drive of a bicycle. And I added this picture of a bicycle because it's going to help us out to understand what's going on. So they say, how far will the bicycle move if the pedals are rotated through 180 degrees? Assume that the radius of the bicycle wheel is 13.3 inches. So that would be this right here. That diameter, or I'm sorry, that radius is 13.3 inches. Okay, they don't show you that. All right, so what do we have here? I mean, we know we're working in trig. Usually we work with circles and triangles. What do you see here? I see three circles, right? I see this circle with the pedals. I see this circle here with back sprocket. And then I see this circle, which is the wheel of the bicycle, which of course matches this wheel. So when they ask this question, the real question is, how far will the bicycle move? That's what I want to know. Well, how does the bicycle actually move? Of course, the friction of the tires, right, helps it propel it forward as I push the pedals, you know. So as the wheels rotate, the bicycle moves forward. But what is it that actually happens? Well, it's the edge of the bicycle is in contact with the ground, and there's enough friction to propel it forward. So what happens is you need to know, what is this arc length here? How much arc length is generated as the bicycle is moving, because that's what's going to measure your linear distance. It's actually a linear distance, because if I were to take this bicycle wheel and split it open and lay it on the ground, it would be a line on the ground. Of course, it wouldn't, the bicycle wouldn't work, but you know what I mean. So I need to find arc length here. And how do I do that? Well, what they gave me is the rotation here. They said the pedals here, this front gear, rotates 180 degrees. Now, what do I do with that? Well, what can I say is the same? Well, I know this is a big circle and that's a small circle, but I know they're connected by this chain link. So obviously the sizes of the circle are different, and we can see that because of the different radiuses, or radii, right? And then this rotates 180 degrees. This is going to have to rotate more to keep up. How do I know they keep up? Because of this chain link. So what is the same is how far the chain link moves along the edge of both of these circles. So what is the same is the arc length for both of these circles. All right, so let me go ahead and label these. I'll label this A, I'll label this B, and I'll label the wheel C. Okay, and this will be the back sprocket, this will be the front gear, and that's the bicycle wheel. All right, so what I do know is the same as the arc length for A and B. So A and B have the same arc length. And we label that with S, arc length, right? And we know the formula for S is S equals theta R, where theta must be in what? What's the measurement? It has to be in radians for that to even, for you to be able to use it, okay? So what I know from A then, they tell me that, let's go ahead and figure out the arc length for the circle A, and that's going to be its theta R. But remember, theta is 180 degrees, but we know that's pi radians. So I had to do that to be able to use that. So the arc length of this circle is going to be pi times its radius is 4.31. And I'm going to write that a little more cleanly as 4.31 pi. Right. All right. So now I know the arc length and basically how much this chain moves around this circle. I can use it now to find the rotation of this circle, because I know the arc length is going to be the same. So using the arc length for B, where I want to say, well, what's the arc length for B? I know it's got to be the same as the arc length for A. Right? But I already know the arc length for A is 4.31 pi, and I know the arc length for B is theta times the radius of B. Well, I don't know theta, that's what I'm going to find, but I do know the radius. It's what? 1.57. So I know that theta times 1.57 is equal to 4.31 pi. Right? So now when I divide both sides by 1.57, I'll get that the rotation that this smaller one goes through, and it should be much more than what the rotation that this one goes through, right? Because this is much bigger. So to cover the same distance or arc length, this is going to have to spin more or rotate more. So this is going to be 4.31 pi over 1.57. Okay. Now, if you notice, I'm not finding numbers, and I'll explain why at the end. All right, so I found starting with A, I found its arc length. Then I used that arc length because it's the same as the arc length for B, which allowed me to find the rotation for B. Right? Now, why did I do that? Well, because what happens is, what makes this wheel move, this sprocket, this back sprocket moves is basically when it rotates, it also rotates this wheel. So they both have the same rotation. So therefore, I can say that this rotation is going to be, this sprocket is going to rotate this wheel. So let's go ahead and find out what is the, here, so this is 1, then we did this, now we're doing here, C, which is for the wheel. I know that the arc length of the wheel is how much it rotates times its radius. But we know how much it rotates because it rotates the same amount as the sprocket here, right? That sprocket is attached to the wheel. They both rotate at the same amount. So here, the arc length for that is going to be the arc length for the sprocket, which we already, I'm sorry, not the arc length, the rotation. The rotation is right here, 4.31 pi over 1.57 times its radius, and they told us that's 13.3 inches. Okay. Now, if you do all this and you put it in your calculator, and let me go ahead and show you how I put it in my calculator, it might help you out. So I'm going to put in here 4.31, right? And I'm multiplying it by pi by 13.3 divided by 1.57. So times, and then I go ahead and pull up pi second, pi times 13.3 divided by 1.57. Excuse me. And I get 114.7041501. And I think they ask you to go round to the nearest tenth, right? So that's the first decimal. So I would say 114.7 inches. So that's the distance, that's the arc length on the edge of this wheel of the bicycle. So that's going to be how far the bicycle moves, because as the wheel turns, the bicycle moves forward. All right, now let me just mention why I carried these numbers and didn't actually put these numbers in right away in my calculator. I didn't put in 4.31 times pi and then round. Let's just say I had done that. And let's just say, because they asked for you to go out to the 10th, let's say I went to the hundredths and I said, oh, I'm just going to go out to the hundredths and I'm going to assume that. So if I were to do that, I'm going to do this in a different color. What I would get here is 13.5402. So let's say I said, oh, I'm going to make that 13.54, right? And that's this part right here. So then I'm going to put 13.54 here, right? And I'm going to divide it by 1.57. And there I would get 8.6242. And let's suppose I said, oh, 8.62. So I'm going out one more decimal place than what the answer asked for. And so then I come down in here, and I've got this, right? So I would have 8.62 times 13.3. And what I'm going to get is 110.6061, which you would say, oh, well, there it is, 110.6. And look how far off this answer is from this one, right? Way off. So this is just an illustration that you might actually get the process correct in terms of what you're supposed to do, but your answer will be way off by a lot. And that is a huge rounding error. and for real life examples, this would be a huge rounding error, and it would be so wrong to use it that even if you got the process correct, you do also have to get the accuracy correct, right? So you really need to. So what's my point? My point is carry it. Don't go ahead and approximate this. I mean, if you do, you're gonna have to go on. I don't even know how many decimals. A lot, probably 5 or 6. But I'm not even sure that would be true. You could play around with it after this video and just see. But really, just write the numbers. You already know the arc length is this, and then you know that to substitute it here, and so on and so forth. And then just carry it. All right. Thanks so much for listening. Oh, let me just move that a little bit in case you needed this. Oh, probably do need to see that. Hold on. So sorry about that. So let's just make sure this is clear. The arc length of the bicycle wheel is theta times r. We found theta here. We were given r. Then we just multiply them and we get that. So I'm sorry that might not have all come out until I focused in a little bit more on that. Thanks so much for listening.